Today, I will introduce how to use the TBS-1000 cable fault location system. Firstly, let's take a look at what it consists of. A tablet, a high-voltage emergency stop box and its connecting wire, a discharging rod and its connecting wire, a ground electrode and its connecting wire. The most important thing, of course, is our TBS-1000 main unit. Let's take a look at its nameplate. Let's take a look at the front. Cool exterior design. This is a protective grounding wire. This is the FU signal detection port. This is a high voltage output line. Contains 2 clips to connect the cable. And there's also the power line. You don't need to worry about the other 3 connection ports for now. Next, connect the high voltage emergency stop box to the main unit. Then connect to FU. First, assemble this ground electron. Insert the connecting wire into the hole of FU. It can detect high voltage operation. Is there a step voltage present? Insert the other end into the hole of the ground electron. Insert it into the ground as an auxiliary grounding. In addition, it is also necessary to connect the discharging rod properly. Next, connect the protective grounding wire to the grounding bar. Connect the high voltage output line to the faulty cable. Red clip to cable core B, as B is preset, there is a fault. Additionally, connect it to the metal shielding layer. Attention, metal shielding needs to be grounded. Next is the power cord. After connecting, power on at the top. The right indicator light is on. The next operation will be carried out on the tablet. We need to connect the Wi-Fi in the settings. The Wi-Fi name will start with TBS-1000. After successful connection, return to the desktop and open the AutoGo app. You will see 3 icons: Intelligent Mode, Standard Mode, Test Database. There is a setting in the corner. Let's take a look at what's in Standard Mode. Analysis. Prelocation. Multiple methods for you to choose from. Pinpointing. Conversion. Let's do it, TDR. Waiting for function switch. Our cable is approximately over 300 meters long. We set a range of 400 meters. Wave speed 172. Obtained a total length of 372 meters. You can also zoom in and observe. Or take a screenshot. You can also move the cursor very finely or make large movements. Let's take a look at the commonly used ARM features. First, a full-length waveform was obtained. Press this button according to the prompt. Remind me that I haven't activated the emergency stop function. Waiting for security self-inspection. We need to set the voltage now. Try 9 kilovolts. Storing energy. The icon lights up. Trigger it. Obtain comparative waveforms. The disagreement lies in the location of the malfunction. Here are 5 trajectories for you to choose from. You can also move it for better alignment. Cut off high voltage on the tablet or through the emergency stop box. Let's take a look at what intelligence mode will do. Prompt us to proceed with DC soon. Start, high voltage closing. Self-check completed. Prompt me to set the voltage. It told me that a breakdown occurred at 5.1 kilovolts. Remind me that the next step is to perform prelocation. Obtain the first waveform. Prompt to obtain comparative waveforms. Waiting for energy storage. Trigger. Tell me the fault distance is approximately 215 meters. The next step is pinpointing. Surging. You can set the discharge cycle here. It can also be set as a single use. Similarly, set the voltage. You can see the energy value of each discharge here. The fault point is being penetrated and making sound. And the test and disconnect the high voltage. Press the emergency stop button and turn off the key. Turn off the main switch. Before removing all wiring, it is necessary to discharge the cable.